Hi there and welcome to another video where we go through some past paper exam solutions for the Edexcel Core 3 Maths A-Level syllabus. In this video I'll work through questions where there are exponential and log equations explicitly that you have to solve. These tend to arise in the middle of other questions, but this video is where I've pulled out the ones where they are explicit and we will solve them. As always, pause the video, have a go, and then mark your work against mine. Okay, first part. Find the exact solution of the following exponential equation. Exact means do not use decimal places. Leave your answer in terms of logs or exponentials, etc. So, how do we solve an equation like this? Well, you take logs, natural logs, of both sides. And then you can bring down the power by the law of logs. So you can bring down the power and say that 2x plus 3 ln e is therefore ln 6. Now you should know that ln e is equal to 1. So you have 2x plus 3 is equal to ln 6. Subtract 3 and divide by 2. X is therefore ln 6. Subtract the 3 and then divide by 2, which I might just write as a half out the front. And you found the answer for the first one. Part 2, solve this here. Well, remember, if 2 cubed is 8, then log base 2 of 8 is 3. I always remember that to help me solve any problems. So this equation here is saying that ln is actually saying ln means log base e. So log base e of 3x plus 2 is equal to 4. Okay, so converting that back into exponent form, you could therefore say that e to the power of 4 is equal to 3x plus 2. So therefore, this next line here, effectively you can think of it as taking exponentials of both sides. If you take exponentials of both sides, 3x plus 2 is therefore e to the power of 4. And solving for x, 3x is therefore e to the 4 subtract 2, and x is therefore dividing by 3, a third, e to the 4 subtract 2, and you're done. Okay, next question, pause, have a go, then watch my solutions and mark. Okay, we'll do the first one. This one says solve, but it says give your answers to 3 significant figures where appropriate. So we can take natural logarithms of both sides, and I would say that ln 3 to the x is equal to ln 5. Bring down the exponent x ln 3 is equal to ln 5, and dividing both sides by ln 3, x is ln 5 over ln 3. Now it asks you to give your answer to 3 significant figures, so you can tap in your calculator natural logarithm of 5 divided by natural logarithm of 3, and you get yourself to 3 significant figures, 1.46. And you're done for part A. Part B, it says solve this here. Now, you can use the log rule. Remember, log of A subtract log of B, if they're to the same base, is log A over B. So you can therefore write that this is the same as log. Our base here is 2. And you can say that's 2x plus 1 over x is equal to 2. You can raise both sides to the power of 2. Or you could remember I said before that 2 cubed is 8. So therefore log base 2 of 8 is 3. You have log base 2 of something is 2. So therefore this is the same thing as saying that 2x plus 1 over x is equal to 2 squared. And we can solve this. So 2x plus 1 over x must equal 4. Times both sides by x. 2x plus 1 is equal to 4x. Collecting x's, subtracting x off both sides. 1 is equal to 2x. And dividing both sides by 2, x is equal to a half. I'd encourage you to substitute it back in. If you had a half there, then that would be log base 2 of 2, subtract log base 2 of a half, and it would work out to be equal to 2. And part C, solve the following in the interval 0 to negative 90. Now, we can say if ever you have ln of a number equals ln of another number, you can say the two numbers must be the same. But currently this negative, it's not ln of something equals ln of something else exactly. You've got a negative. So what you could do is you could bring the negative 1 up into the exponent. So ln of sec x, all of that to the minus 1. Now remember what sec is. Sec x is 1 over cos x. So if I was working out sec x to the minus 1, that's 1 over sec x. Well, it's 1 over cos x, which flips the cos x. It's just cos x. So therefore, this is the equivalent of ln sin x is equal to ln of cos x, because sec x to the minus 1 is actually cos x. And therefore, what we're solving, ln of something equals ln of something else. Therefore, the expressions inside the logarithm must be the same. So we're solving sin x equal cos x. Divide both sides by cos x, you get tan x equal 1. And to work out your first value, x is therefore the inverse tan of 1, which you type in your calculator, and your calculator's in degrees mode. So inverse tan of 1 is 45. So x is equal to 45 degrees. There's no other solution between 0 and 90 where x is 45. That is your only answer. Okay, next. Okay, part A, we have ln x plus ln 3 equals ln 6, where you can use the rule that log A plus log of B is log A times B. So using this here, we could say that therefore ln x times 3, which is 3x, is equal to ln 6. This is log base e, ln is log base e, so they have the same base. The numbers inside the natural logarithms must therefore be the same, so you conclude that 3x is equal to 6 and x is equal to 2. And you're done. Part B, we're trying to solve this here. So we have e to the x plus 3e to the negative x plus 4 equals 4. Now currently that we don't have the same exponent here, so it's a bit confusing. So I would just convert that as a first instance into this. Then I would be encouraged to multiply everything by e to the x. So to remove e to the x from the denominator here. So e to the x times e to the x we get here. We just get plus 3 here is equal to 4e to the x. Now e to the x times e to the x is e to the x plus x, which is e to the 2x, plus 3 equals 4e to the x. And subtracting 4e to the x off both sides, e to the 2x subtract 4e to the x plus 3 equals 0. Now, making the substitution, if you need to, y is equal to e to the x. This would be y squared minus 4y plus 3 equals 0. So factorising y subtract 3, y subtract 1 equals 0. So y is equal to 3 or y is equal to 1. Now we didn't want y, we wanted x's in the end. So you should have continued down the page here. I'm just working over here because I've run out of a bit of space here. If y is equal to 3, then e to the x is equal to 3, or e to the x is equal to 1. Taking logs of both sides, this would get me x is ln 3. Taking natural logarithms of both sides, this would get me that x is ln 1, which is 0. That's one answer. That's the other answer. I'm done. Okay, next question. Okay, let's work through this part by part. Find the exact solutions to this equation here. Log base e, or ln 3x minus 1 is 5. You can take exponentials of both sides to get that 3x minus 7 is e to the power of 5. To solve for x, add 7 to both sides and then divide by 3 over 3. You may see in the mark scheme this is written as a third 7 plus e to the power of 5. And you're done. Solve this here. Now, an obvious temptation here is, this is 3 to the x, don't write this down, e to the 7x plus 2. Obvious temptation is to somehow combine these to 3e to the x plus 7x plus 2, and maybe even 3e, therefore, to the 8x plus 2. You think combine these and combine these powers. No, you can only combine powers of, you can only combine indices if the base number is the same. The base number here is 3, the base number here is e. We can't do that at all, so don't even try. What we could do is just take luns of both sides and see what happens. So ln 3 to the x, e to the 7x plus 2, their timesing is ln 15. Now you should know that ln a plus ln b is ln a times b. We've got an a times b here, so we can split these by the laws of logs into ln 3x plus ln e to the 7x plus 2 is equal to ln 15. Now you can bring down this exponent and this exponent by the laws of logs that say that log of a to the b is b log a. So this would say x ln 3 plus 7x plus 2 ln e is equal to ln 15. Now ln e is 1. You know that ln e equals 1. So therefore this says that x ln 3 plus 7x plus 2 equals ln 15. So let's combine x's here. This I could factorise out the x from these two and say that x ln 3 plus 7 plus 2 is equal to ln 15. Could subtract 2 from both sides. X ln 3 plus 7 equals ln 15 subtract 2. And then lastly I could divide both sides by the ln 3 plus 7. X must be ln 15 subtract 2, all divided by ln 3 plus 7. Tap that in your calculator. And you should get x is equal to 0.0874 to 3 significant figures, and you're done. Okay, next. The functions f of g are defined as follows. Find the inverse function and state its domain. Well, our function f of x is equal to e to the 2x plus 3. 2x plus 3. When finding the inverse, I let y equal e to the 2x plus 3. I'm going to try and make x the subject of this formula. Just as a little aside, you don't need to write this here, but this is an aside I'm going to rub out. You've currently got y is equal to e to the 2x plus 3. To get the x down, as it were, I would take logs of both sides, or luns. The problem with doing that as it stands is I can't use any rule to break up this e to the 2x plus 3. I'm a bit stuck at this point here. There's nothing I can do. So what would be more helpful for me is to subtract the 3 off both sides first. Let me show you what I mean, why that works out better. Because the x does not get stuck anymore. If I subtracted 3 off both sides, so I got y subtract 3 is e to the 2x. Then if I took luns of both sides, so ln of y minus 3 is equal to ln of e to the 2x. Now I can bring down the power of 2x. So 2x ln e is equal to ln y minus 3. And ln e is of course 1. So 2x is equal to this. So in particular x is equal to a half ln y subtract 3. And finally then, to state the inverse function, therefore f to the minus 1 of x, and putting in x's here is a half ln of x subtract 3. And that is your inverse function. What is its domain? Well, its domain is the range of the original function. Its domain is the range of the original function. And if you think what that graph looks like, e to the x looks like that, e to the 2x will look like this, and e to the 2x plus 3 will look like that but moved up by 3 there, and asymptoting at y is equal to 3. So the range of this graph is y is bigger than or equal to 3, so the domain of this graph is x is bigger than or equal to 3. And you're done. Okay, next, find fg and state its range. Fg, remember, this actually means take f and put in g of x into it. Now, our f is e to the 2x plus 3. What's our g? Our g is ln x minus 1. So our g of x is ln of x subtract 1. And we're going to work out f of g of x, which is f of ln x subtract 1, which is equal to e to the 2 ln x subtract 1 plus 3, which is equal to e to the 2 ln x subtract 1 plus 3, which is equal to e, you can take this power up inside the ln, so that's e to the ln x subtract 1 squared plus 3. Now e to the ln of f of x is always f of x, so this must be equal to x minus 1 squared plus 3, which if you expand it, and there you're done. That is your y is equal to x minus 1 all squared plus 3. Now that handily happens to be the square version of a quadratic. So drawing it, it's like an x squared graph, but it's been shifted right by 1 and up by 3. So its minimum is 1, 3 here, and the graph would look something like this, an x squared, where you end up crossing at 0, 4 here. Okay, so it's as simple as that. So therefore, what is the range? Well, y must be bigger than or equal to 3, and you're done. And next question. Okay, going through bit by bit, f and g are defined as follows. Prove that the composite function gf is as follows. Remember what gf is. Gf means work out f of x and then put it into g. So what we're working out is g of 2x plus ln 2, because that's what f of x is. So what we're working out is e to the power of 2, 2x plus ln 2. Instead of x, we're putting in 2x plus ln 2, which is equal to e to the 4x plus 2 ln 2, which is e to the 4x. Remember, for some number, let's say e to the a plus b, that's e to the a, e to the b. Okay, so here this would be e to the 4x multiplied by e to the 2 ln 2, which is e to the 2 ln 2 is 4, because e to the 2 ln 2 is the same as e to the ln 2 squared, which is the same as 4 squared, 2 squared, which is 4. So this is equal to 4 e to the 4x, and we're done. And we have done exactly what is asked for in this part here. Next, in the space provided, sketch the curve y is equal to g f of x and show the points it crosses the axis. Well, you know y is equal to 4 e to the 4x, and the question is, what does it look like, and plot where it crosses the axes. I'll rub these out in a second, but this is e to the x. Crosses at 0, 1. Okay. E to the 4x would be slightly underneath it this side, not touching, shouldn't be touching there, but coming up quicker that side, so that would be e to the 4x and this here would be e to the normal x, and 4e to the 4x, well, that would just be like this here, but instead you cross that 4 instead, so you would cross at 0, 4. Okay, so drawing that then, rubbing this out and drawing that all in one move, just to show you where it came from, the graph would look something like this, where that point there would be 0, 4, and you're done. Okay, next, write down the range of GF. Well, looking back at your graph, GF, the range is all the y values, and all the y values it can take are bigger than or equal to 0. So what is the range of GF? Well, GF of x is always bigger than 0, not equal to 0 actually. It never touches 0, it asymptotes towards 0, so GF is bigger than 0. And lastly, find the value of x for which if you differentiate g of f of x, you get 3. So what you want to do, you want to differentiate g of f of x, which is 4e to the 4x, and you want to solve that equal to 3. Differentiating this by the chain rule, you differentiate the exponent here, and you keep the function as it was. You're trying to solve that function, i.e. 16e to the 4x is equal to 3. Divide both sides by 16, e to the 4x is 3 over 16. Take luns of both sides, so that 4x is equal to ln 3 over 16. And finish off by dividing by 4, x is equal to a quarter ln 3 over 16. And you're done. If you type that into your calculator and round to 3 significant figures, you would get negative 0.148 to 3 SF, and you were finished. And that's all for this video. In this video we've recapped the past paper questions that require you to solve exponential equations and log equations. Tune in for another video where we work through all the exponential rate of cooling and rate of decay questions. Thank you very much for watching.